Along with individual experts, Surgeon Masters brings you life improvement strategies in 10 minutes. These proven principles and strategies are easy to learn and can be applied immediately, allowing you to practice your best. Here's your host, Jeff Smith.
On this episode of the Surgeon Masters Mini Podcast, I have with me physician scientist and SciDoc founder, Rachel Draelos. Rachel, thank you for being with me.
Thank you for hosting.
So the topic that we talked about today was an area of expertise in technology and AI, and some physicians are a little nervous about it. So I thought we could have a really nice conversation about that today. What do you think?
I think that sounds great. It's one of my favorite topics.
So tell me a little bit about what got you into it in the first place.
I did my training at Duke in the MD PhD program and initially was planning to focus mainly on computational genomics. But at the start of my PhD, several different people all pushed me to investigate AI. And that's when I first became really interested in AI and ended up pursuing a PhD in the area. And during my PhD training, I became really excited about the potential of AI to help not only patients, but also physicians, and in particular, help alleviate a lot of administrative burden that physicians are currently experiencing. So that's how I first got interested in the intersection of AI and healthcare.
I talk a lot about wellness, burnout, physician frustrations, and all sorts of things. And certainly the EMR is probably one of the leading areas. Tell us how this might be a rainbow that we should be following.
Yes, so EMRs are definitely a big issue currently, and I am very interested in building a new EMR. That's actually the main mission of my startup company, SciDoc, is to build the first AI native EMR that addresses a lot of the issues with current EMRs. I look at EMRs as having a couple different facets that are currently broken. One is that the user interface is often very confusing. And another is that the underlying data is very messy and fragmented, which really limits not only what you could do in the interface, but also limits the potential of AI in healthcare. So something that I'm working on and that I'm really excited about for the future is a new kind of EMR where not only is it really easy to use in terms of the interface, but also the data has been specifically crafted to unleash the power of AI in medicine to help with all kinds of different things that doctors don't want to do and maybe shouldn't be doing, lots of administrative kinds of tasks.
I think a lot of people have heard about AI, and I think there's sort of mixed views on how much of it is really exciting and how much of it makes us nervous. But the other thing that's sort of tricky is your scientific and computer science background really gives you a lot of knowledge that we don't have. So how do you sort of simplify this conversation for both those groups, the people that are excited and the people that are nervous?
There's a couple different ways to think about AI. And one thing that's helpful is thinking about different kinds of AI. So there's different subcategories. AI as a field is really, really broad, and it just refers to any kind of computer software that appears intelligent. So that includes, in one example, rule-based systems. That could be potentially a very long collection of rules, like if you see this piece of information in a patient record, then do this, and specifying it all out like that. What has been really changing the field of AI a lot recently is the subcategory of machine learning, and specifically a further subcategory of that is a specific kind of machine learning model, which is a neural network model. There's a lot of stuff out there that says, oh, neural networks are like the brain, and there's reasons that maybe people are saying that, but there's also reasons that it's not necessarily true at all, that they're pretty different. But ultimately, what neural network does and what a machine learning model does is you give it data rather than rules, and then it figures out certain concepts from that data depending on how you configure it. So a lot of the recent advances that have been happening are in that area of machine learning. And I think it's like all new technology, a double-edged sword, where you have possibilities that are very exciting. And then the flip side is that there's potential for misuse or downsides of the technology. And I am a huge proponent of AI safety as well. So I think it's critical to be really responsible with it.
It sounds like, in particular, that you're coming at it from the angle of the physician, not the computer scientist. And that's a really critical component. So, I mean, obviously that impacts the product, but how would you explain that this just isn't data that the physician doesn't have control over or something like that?
I do think having the perspective of physician is really critical when developing both EMRs and AI tools for healthcare. And I think that part of the reason that current EMRs have so many issues is that in a lot of cases, they were first developed for administrators and then kind of retrofitted for clinical use. And then also at a lot of different EMR companies, there is no physician involvement in development of the product at all, which is a little bit mind-boggling, but that explains how you end up with systems that are very confusing and difficult to use for clinical care. So definitely it's a top priority of mine to not only use the training that I've had where I'm using an EMR from the clinical side to make something better, but also engage lots of other physicians who have experience in a wide range of specialties to help make sure that the way the software is put together makes a lot of sense for how it's actually going to be used.
And it could be just me, but the way you explained one part of AI as being if then, like that conceptually is a concept that I think many physicians can appreciate, or at least I feel I can. How would you explain the second one that you were describing in data as far as something simplistic like that?
So for machine learning, which is pretty much every time you hear in the news about some huge AI company doing something, it's a machine learning model. The way machine learning models work is that they learn from data without being explicitly programmed. The way I like to explain machine learning is that you pick a task that you want the model to do, and then you specify in an equation what it means to do well at that task. So to take a specific example, let's say I want to identify if a picture of someone's pet is a dog or a cat. Then the output of that could be 1 and a 0 or a 0 and a 1 or something for whether it's a dog or a cat. And so if you get it, right or wrong, that's just comparing what the model predicted with what you know is the correct answer. And that equation is called the loss function. But basically, it's just measuring how right or wrong the model is. And the way these models work is first you set them up so that they're all the parameters, so all the numbers that determine how it behaves are just random. And that means that when you first set it up, it doesn't do anything. It just produces garbage. Then you go through the process of training where you have a big data set you collected with a bunch of pictures of people's pets and a label for it's a cat or a dog. And you show one example at a time to the model. The model at first was just going to make random guesses. But what you can do is you can compare this prediction that it made, some probability of it being a dog or a cat, and then compare that to what you know the correct answer is with this equation that you've come up with. And then there's this algorithm called backpropagation, which is essentially a way to make little tweaks to the model to make it slightly less wrong the next time around. And then you do that over and over and over again. So every example it sees, it gets slightly less wrong until all of a sudden you get this model that is doing things right a lot of the time. And it's really surprising the kinds of sophisticated behavior that can arise from this relatively simple setup, where if you look at large language models like ChatGPT, ultimately those are next word predictors. So the task that they're trained on is just predict the next word. And then they have these huge data sets scraped off the internet where it's just going through and basically predicting the next word. And that's the piece of math that it gets trained on is, did it get the next word right? And then there's all these crazy emergent properties, really interesting intelligent behavior that arises from that, which honestly, people in AI don't actually understand. People don't actually understand where that intelligence is coming from in the large language model. The architecture is known, but that emergent behavior isn't. And that's a super interesting area where it's almost like doing neuroscience on a model.
Well, that's super interesting. It sounds like, though, the key for our audience is figuring out how to leverage tech to improve processes that they deal with. And I'm wondering if you could just kind of summarize that take home of what do you think our audience can do to learn more?
Absolutely. So there are many different ways that AI can potentially reduce, in particular, administrative burden. And so a good next step would be to identify some key area of administrative burden like note writing, billing or coding, or prior authorizations, some administrative task, and then spend some time just on Google looking up AI solutions that can fully or partly automate that task. And I'm happy to be a resource to answer questions about it. My particular focus is on automating note writing, and that's what the current product my company has. But I also know a lot about other areas in the space, and we'd be happy to answer any other questions on it.
Well, that's fantastic. We're going to encourage them to do that and to reach out to you if they want to learn more. Thanks for joining us.
Thank you.
There you have it. In less than 10 minutes, this is Jeff Smith, along with Dr. Rachel Draelos. Until the next episode of Life Improvement Strategies for the Surgeon Who Wants More. Ciao.
Now, take 10 minutes and put your plan into action to practice your best.